chapter 4. Let me get some more light here. All right, there we go. So today we're going to be starting chapter 4. We're moving into a place that most of you are going to be a lot more familiar with. So chapter 2, set theory stuff. Chapter 3, the logic stuff. Probably not as familiar to most of you, probably. Chapter 4, though, the title of it is Rates, Ratios, Proportions, and Percentages. So you've definitely heard all of those words. There we go. Hang on one second. All right. So you've definitely heard all of those words: rates, ratios, proportions, and percentages. First, we're going to talk about just rates and unit rates, which is the title of the first section. Then we'll get into ratios and proportions, and then we'll get into percentages. And then, this pretty much, the name of the chapter pretty much sums up what we're going to do in the entire chapter. It's just going to be these 4 mathematical objects, and a lot of the problems are I'm going to say pretty much all of the problems are going to be like real life problems. Like, I will very rarely just be making up numbers that don't have any like real meaning attached to them. So this is very much like quote unquote real life math for the lay person, meaning for like just your average person. This is real life math. Okay, so let's get into rates and unit rates, which is section 4.1. So real quick, a rate is just a fraction. A rate is a fraction. So something over something. I'm reading what the book says. I'm trying to think of a better way to say it. Used to compare two numbers, that's fine, that are not necessarily the same units. I'm going to tell you what units means too. Not necessarily the same units. Okay, so a rate is just a fraction, a fraction of numbers that has 2 quantities, top and bottom, that are used to compare those numbers, and they are going to have units attached to them. So for instance, I could say just some arbitrary rate here. Let's see. Maybe the cost of gas. The cost of gas is a rate. It's I'm just going to make something up here. $2.95 per 1 gallon. So the units in this rate are dollars over gallons. Okay. Dollars over gallons. So the units are just the thing, whatever it is, the measurement attached to the number. So in this case, it's dollars. In this case down here, it's gallons. It could be, anything you can think of that can be measured with a number. Definitely like any measurement, like linear measurement, like inches, feet, meters, all that kind of stuff. We'll deal a lot with money because, you got to know a little bit of math to deal with money, and everyone has to deal with money, right? So we'll do a lot of that. Just anything you can think of that can be measured with a number can be a unit. And the order of the ratio is important too, by the way. So in the homework, they're going to ask you, they'll tell you something like, you know, the cost of gas is $2.95 per 1 gallon. Write this as a ratio, or sorry, write this as a rate. Then you're going to need to make sure that you put it in the order they ask for it. I'm going to make a note here. Typically, when money is involved, it should be in the numerator. Because we don't really, like, if I asked you the cost of gas, you wouldn't tell me, you know, you wouldn't say it's 1 gallon for $2.95, which you really could. That would mean the same thing here, but most of us are going to say it's $2.95 per gallon, right? This will make more sense with some problems later on. I'll point this point out again, and you'll see what I mean there, how it's much more natural for us to consider money being on top. And by the way, I'm saying money, not dollars, because we are going to have, I've looked at the homework a second ago, and we do have some examples that are using like the euro, just money that's not dollars, not American dollars. That's why I'm being vague about money here. Yeah, Kevin, what's your question?
I just needed a real quick review. Which one's the numerator? Which one's the denominator?
Oh, sure. Yeah. Numerator's on top.
Thank you.
Yep. Yep. So this is the in general for a fraction, the top is called the numerator and the bottom is called the denominator. Cool. Alrighty. Now, let's just practice using some rates. I'm going to go into example 1. This is from the text. Actually, it's 2 from text. Example 2 from the text. I kind of already talked through what they do for example 1. So let's say this food store called, oh, by the way, since a lot of these problems we're going to be doing are real life problems, meaning word problems, you're going to have to be watching me write long problems. So 30 pounds of candy. So I apologize for that. So 30 pounds of candy, which is a whole lot, for $64.49 on its website. Which of the following fractions and what am I going to say here? Which of the following fractions I'm going to say represents this rate they give this 30 pounds for $64.49. So A, here's our choices. A, 1 over 64.49 with dollars attached to that, but no unit attached to number 1. Answer choice B is 30 pounds over, LB is pound, LB is the abbreviation for American pounds, and 64.49. Answer choice C is 30 pounds over just 1, and answer choice D is 64.49 over 30 LB. Okay, so there are technically two right ways to write this. The things you're looking for are, first of all, for both numbers to be involved, right? So like A and C are just completely wrong because this one straight up ignores the 30, right? The 30 pounds, and C straight up ignores the dollar amount. So A and C are just wrong straight out of the gate because they don't even involve like both numbers. A rate should be a fraction that compares two quantities, right? But each of these only has one technically. Now, I said before that typically we write money in the numerator, so you would say D, but really technically there are two correct answers here. So we would say, for the purpose of math class, right, B and D. So let me write this down. Let me write down what I'm saying so you can see it. Technically, both B and D are correct. And why do I know they're correct? Well, both quantities are involved, the 30 and the 64.49, and they have the appropriate unit attached to them. Like notice that the 30 has the pounds, right? So it's not like $30 over 64.49 pounds, right? It's the appropriate unit attached to each of the numbers in both cases. So technically, excuse me, both B and D are correct. That's what you would select if this was like a homework problem or a test problem. You would say B and D. I'll say in real life, though, we tend to use D, answer choice D there, right? We tend to put the money over the pounds, or the money over whatever the other unit is. Okay. Okay. So, yeah, let's see. Let's talk a little bit about unit rates and what those are and why they're useful. And so example 2 there, or rather I'm calling it example 1, was just about identifying what a rate is and just how it should look and like how it can go wrong if you try to write it down. Okay. So example 2 now. We're gonna have a rate given in words, and we're gonna use that to find the unit rate. Okay, so I'm looking at example 3 from the text. I'm gonna not write the entire problem because it's not all relevant. Let's see. Okay, here we go. Katie's car. Oops, car. Claims a fuel efficiency. Here we go. Claims a fuel efficiency of 29 miles per gallon. Now that's a rate. When you see MPG, if I really like expanded that out in the terms that we're, in the way we're writing them, it's 29 miles. And I'm not going to, okay, hang on, miles per, I'll talk about the miles versus M here. Just give me 1 second. And then the P stands for per, which means that's where the fraction bar is. And then G is 1 gallon. So I'll abbreviate gallon, GAL. Now, the whole miles thing, in SI units or the metric units, little m stands for meters. So as Americans, well, at least as people living in America, we all should know that MPG, when it says MPG, that means miles per gallon. But people who maybe aren't from here or don't live in America would be confused about that because they would think it would be meters per gallon, or, well, they don't use gallons either, so they would think it would be meters per gram, which makes no sense. But anyways, So just so you know, the MPG means miles per gallon, just like this. And when you do write it out, if you're going to expand it into this rate format here, you're not going to want to just write an M up there. If you're going to expand it out, you should write either at least MI for miles. I'm just going to go ahead and write the entire word here. Okay, so her car claims that on the highway. On the highway. So like in the ad or something, that's what it claims. Now, Katie drove how many miles? 309 miles on 11 gallons of gas. Oh, on the highway. It's implied on the highway. So the question then is, of course, what is the question? What is the car's actual MPG? So like she went out, tested it, drove it 309 miles on the highway. That burned 11 gallons of gas. What is the car's actual MPG? How does it compare? To the claim. All right, let's solve this. So the given rate that we're comparing to is 29 over 1. We'd like to compare 29 over 1, 29 miles per 1 gallon, to, and now I need to write a new rate, right? 309 miles in the same order. You know, it's miles over gallons, over 11 gallons. But how do we compare fractions? How do we compare fractions? Does anyone remember if you've recently taken whatever the class is, LS 106? How did you learn to compare two fractions in there? Does anyone remember? Okay, we have to get a common denominator. We need a common denominator. Okay, we need a common denominator. Now, so typically what we would do is look at the two denominators and maybe try to bring one up to meet the other and then compare the numerators, right? Oh my gosh, hang on one second. My phone is going crazy. I'm about to turn this thing off. Or just throw it across the room so it quits bothering me. All right, there we go. Okay. So normally we would probably take this one and bring it up to match with the 11 down there. But when we're dealing with rates, we're going to find that often it is very useful to always bring the denominators down to 1. So for our purposes, we will bring the denominators down to 1. Now, of course, one of them already has that, so it's really just about working with this one. Now, why are we going to bring it down to 1? Well, because 1 is a very natural denominator to have, right? When you say your car claims 29 miles per gallon, you're telling me that it gets 29 miles for each single gallon, right? If I told you that my car got 58 miles per 2 gallons, which is the exact same as this, 58 miles per 2 gallons, you would look at me like, why are you making me do math? Like, just tell me the rate, like per gallon, right? Don't tell me per 2 gallons. Just tell me this one. This one is so much more natural, right? We can almost like picture this, right? As soon as you start messing with the denominator, it gets harder to imagine like how efficient this actually is. So we're going to bring the denominators down to 1. This one obviously is fine. That one was given with a denominator of 1. How do we get this one there? How do we get this one there? Well, just divide. Just divide. In fact, I'll tack that on right here. We will bring the denominators down to 1 by dividing. And what do I mean by that? Literally do 309 divided by 11. Okay. So just for fun, you could do it by hand, even though you can just use a calculator. So let's see, 11 goes into 30 twice. So you've already gotten the answer by dividing, but I am going to do it by long division, just in case you've never seen this or forgot. Here's a little decimal long division for you. Let's see, that would be 0, and then 11, so drop another 0. That would be 9, and then that's going to be 99. It's a 1. And then really to go, let's see, that would be another 0. I need to get into the thousands place so I know what to round it to. There we go. So we should end up getting 28.09 mpg. So if you're a sane person, all you did was plug it into the calculator, and you get that 309 miles per 11 gallons is equal to 28.09 miles per gallon. So I could say mpg, or I could write it explicitly like expanded as a rate here. 28.09 miles per 1 gallon. Okay, now we can easily compare these two fractions, or these two rates, right? 29 is bigger, right, than 28. So their claim, I mean, it's not off by much, right? Maybe we can forgive them for this, but so their claim is 29, so, and our actual MPG is 28.09. And by the way, now that they both have a 1 in the denominator, I'm just directly comparing the numerators, right? Once both of the denominators are 1, you pretty much ignore them and you're just comparing the numbers on top, those numerators. So by the way, why might this have happened? Because, you know, this number they get for the claim in their ad or whatever for this car, it's coming from, you know, tests they do, I'm assuming, like in a wind tunnel with a perfect setting, you know, and maybe when she was driving on the highway, she got slightly less because it was windier that day, or who knows, you know. But it's pretty close. It's pretty close. Or maybe she needs, you know, to pump up her tires. Maybe that's it. Anyways, that's finding a unit rate is what we just did there. So I'm going to get us caught up here with what we just did. So this is a new definition here. A unit rate is a rate, first of all, is a rate. They're still rates. Where the quantity being measured in the denominator is a 1. Let's see, is that how I want to say it? Yeah, that's fine. That's fine. It's a little bit informal, but that pretty much gets to the idea of it. Let me, sorry guys. What is going on with my camera? There we go. That's a little bit better. Okay. A unit rate is just a rate where the quantity being measured in the denominator is a 1. So actually the very first example I gave with that 295. So like cost of gas, that 295 per 1 gallon, that's a unit rate. That's a unit rate. Or the thing we just found, 28.09 miles per gallon. So these are measuring two different things, right? This is the cost of a gallon of gas. This was her car's miles, but her car's MPG. But they're both unit rates because they both have a 1 in the denominator. They both have a 1. The thing being measured in the denominator is it has a 1 attached to it. It's very natural. This is how we like to see rates. This is how we like to see rates. Let's do another example. I'm just going to call this a quick example just to send this definition home, right? If rice costs $7.99 for 5 pounds, determine the cost per pound of rice. I'm pulling this problem from one of the little quote unquote skill checks from the textbook. Those are pretty good. Those little problems, they basically like solve an example for you and then give you another one to try on your own. And I believe they put the answers to them are in the back of my section, like at the end of section 4.1, I have the answers to the skill checks, but that might be because this is an instructor edition. Anyways, okay, so how are we going to do this? We've got a unit, or we've got a rate. We've got a rate with money, 7.99 over 5 pounds. I'll say LB for pounds. That's LB for pounds. Determine the cost. Well, I'm not going to do the long division this time. I'm just going to divide. So I'm going to whip out the calculator and say 7.99 divided by 5 is 1. So I'm getting 1.598. So we need to talk about rounding issues, right? So let me point this out off on the side. 7.99 divided by 5 gives 1.598. But when you're dealing with money, you always round to the 100th place. Well, when you're dealing with American money, I don't think the issue's gonna come up where you're gonna have to round with like euros or whatever. I don't know what they go to. I don't know if they go to the 100th place, but so let me say this, when dealing with American dollars, always round to the 100th place. And by the way, where is that? The 100th place is this position here, where the second position behind the decimal point. So that means over here, I'm going to say that this is in dollars 1.60, right? Because I'm looking at the 9, I'm saying, how do I round it? Well, looking at the 9, the digit previous to it is bigger than or equal to 5, right? So I round up, so I round up. When you round a 9 up, it carries over into the next digit, right? When you round a 9 up, it becomes a 0, and that carryover falls into the next digit. That's why that became a 6. So this becomes $1.60 per 1 pound. An example of where you will see unit rates, if you shop at Walmart, on the price tags at Walmart, you will see, I'm not sure if I don't think other stores do this, maybe some of them do, but you'll see the price of the object, like it'll say like 7.99, and then it might even say like per 5 pounds or something. But up in the corner, you'll actually see the unit rate. It'll say like 1.60, and then it'll say per pound or something. I can't fit it, but they'll have the unit rate. If you've ever looked at a barcode, or not a barcode, a price tag at Walmart, they have the little unit rate stuffed up into the corner. And you know, you might say, oh, that's cool, they're being helpful, but honestly, I think the reason for it is because they have that Great Value brand, and their brand is always cheaper, right? So they know, like, the fiscally responsible person that knows about these unit rates is going to be looking there and say, oh, look, the Great Value rice is, you know, $8.99 for 7 pounds, which is a cheaper unit rate, so I'm going to get the Great Value kind. You know, I think they have a little bit of motive there for showing us that. But anyways, okay, so that's unit rates. Okay. So hopefully you believe me that unit rates are super important. Rates and unit rates. I mean, I feel like if you've ever been shopping on a budget, then you believe me at this point that this stuff is important. Okay. Let's talk about proportional equations. A proportional equation. Are we doing on time? Yeah. A proportional equation is, I don't want to say, let's see, is an equation, I'm just going to keep it simple here, involving two rates. All right. For instance, if I said that Katie's car gets 29 miles per 1 gallon, I could also say that she gets 58 miles per 2 gallons. And where is that coming from? Well, it's coming from me knowing that if I scale everything up by 2 here, both the 1 and the 29, then I get an equivalent ratio, or well, an equivalent rate. So I'm getting an equivalent rate here. And that's all a proportion is. A proportion just means if two things are proportional, that means that the ratio of the things is equal. Like the fraction is equal to the fraction. Okay. All right, so how is this useful? Well, example 3. Here's a question. How much gas should Katie have used after driving 243 miles in her car that boasts 29 mpg. So so if she's going off of the ad and she says, well, I'm like on a budget and I know I'm about to make a trip to so-and-so and back, and it's going to be 243 miles. How much gas do I need to get? How much gas do I need to get? How many gallons? How many gallons? Okay. And her first mistake might be just going based off of this MPG, because again, we should know, just as consumers, we should understand that this number is coming from, you know, tests in a very controlled environment. So, but that's okay. She worked with this number, so we'll work with this number as well. So what do we do here? We set up her proportion. We say, okay, she's got a 29 mile per 1 gallon rate. She wants that to extend to 243 miles. So now the question is, I know this is a question of solving a proportion. Where do I put the 243 miles? Well, they should line up. The units should line up across. So if miles is in the top, then that needs to go up top on the other side as well. And then down here, I'm looking for a number of gallons, right? So I'll just call that X. X number of, I could say gallons, so it's still measured in gallons. So X number of gallons. Okay, so recall to solve a proportion, you may be tking of the cross-multiplying method, but really the appropriate thing to say is, here, I'm going to write this out in explicit steps. I won't do this every time, but for the first one, I'm going to do it. Let me rewrite this so I have something to write on. Okay. Step one, you're going to do two things. You want to get X out of the denominator, so you're going to multiply by X on both sides. By the way, in my next step, I'm just going to be dropping all these units. To do my math, I don't need to know all of these units, right? I've got the units lined up in the appropriate spots. That's what I need. So X times 29 over 1 is just going to be 29X over 1, which is going to be now X times 243 over X. Over here, the X cancels, right? So I'm just left with 243. Now here, since my denominator is just a 1, you could just kind of ignore it, right? You can just rewrite this as 29x equals 243. But just in case you ever have to solve a proportion where it's not a 1, I'm going to show you what you would do at this point. You're going to multiply by that denominator on both sides, okay? Now, of course, it's just a 1, so nothing really happens, right? It cancels on this side, and over here, 243 times 1 is just 243. Now, if you're saying, that's just cross-multiplying, well, yeah, that's the point. Cross-multiplying does both of these steps at once. It gets rid of both denominators at once when you do the cross-multiplying thing. This times this equals this times this. But just in case you've never seen why that was legitimate, if your teacher in high school or whatever just said, just cross-multiply, what's really going on is you're multiplying by the denominator on both sides. Okay, how do we finish solving this? Well, we divide. We divide by 29 on both sides. So I'm going to do divided by. Why am I dividing? Well, it's attached to the X via multiplication, so I'm using the inverse operation, which is division. That's going to allow me to isolate the X. And over here on the right side, handy dandy calculator coming out, 243 divided by 29. I'm getting. Now, what were we solving for? We were solving for how much gas. It didn't tell us what to round to. So I'm just going to round to the 100th place, which would be 379. So I'm going to round to 38. And by the way, this is in gallons. We should note the unit at the end. X was in gallons. Cool. Here's a extra question. Because if she was dealing with this in real life, what she'd really want to know is this. If gas costs $2.95 per gallon, how much will she spend on this trip for gas? So we already answered the original question was how much gas will she need for 240 miles in this particular car? And the answer is 8.38 gallons. But really, like her motivation for her question is probably, in the real world, it's going to be how much money is this trip going to cost me for gas? And how do we figure this out? Well, if we know that the cost is $2.95 per 1 gallon, and we've got 8.38 gallons, we're going to multiply. And probably this makes intuitive sense to you, right? But if I really wanted to explain to someone who like this doesn't make intuitive sense to, I would say make it so that when you do whatever operation you're going to do, that the units cancel, the gallons should cancel, right? And I should end up with just a dollar amount. That's kind of the point of this little problem I've written in blue, is that we're going to end up with just a dollar amount, not dollar amount per gallon or anything, just straight up dollars, right? So I need to make sure that the gallons, the unit of gallons, gets canceled out. And if I set it up this way with multiplying the rate, the cost, by the number of gallons, then that unit, gallons, will literally cancel out just like that. And I'll end up with just 2.95 times 8.38. So 2.95 times 8.38 is $24.72, if I round correctly. Just in dollars. That's the only unit that is left over. Okay. Okay. Let's do a little bit more practice with unit rates. And then we'll be done. So example 5, right? Yeah. No, 4. One second. Okay, yep. Example 4. So this is 6 in the text, example 6 in the text. Just going a little bit out of order today. Now they give us this table for this example for exchange rates for American dollars versus a euro, and then different other types of money. So let me quickly draw the table, though you can just reference it on page 150. Okay, so or better yet, I have a better idea. It'll be faster than me writing it down. Let's go here. Let's go to student dashboard. I'm going to go to my ebook. I'm going to go to my ebook, take a screenshot of this page, and put it in the chat. How is that for being more efficient? Oh, right. Just give me 1 second. The ebook is loading. Yes, page 150. Loading. There it is. Zoom in a bit further. Actually, no, that's good. That's good. Screenshot, and then back to Teams. Go to the chat. No, I don't want to send a GIF. I want to. Oh, where's the attach? Oh, there it is. Upload. Sorry guys, just 1 second. Screenshots, there it is, nice. Send. Cool, so you can click that screenshot and, well, it's still sending. There we go. And you can have it open on the side if you'd like while we're doing this example. All right, so it says for part A, it says, what is the unit exchange rate? So it's asking for a unit rate, a unit exchange rate for American dollars, which I'll use our symbol, American dollars to euros. And I forget what their symbol is. It's like a fancy, like, E looking thing. I forget what it is. Anyways, what is the unit exchange rate for American dollars to euros? And notice part B says the same thing, sort of same thing, except they say euros to American dollars. So is this going to be the same answer? Or what's going on here? Well, it won't be the same answer because the direction of, or the order that we write these down is going to be different. The first one is going to be dollars, American dollars over euros. So when we write this down, we're going to say, we're going to say that one second. Okay, yeah. So I had to pull the table back up. Okay, American dollars. So some number of American dollars per 1 euro. Well, they say in that first column that they tell us what the 1 euro is equal to. That 1 euro is 1.351 American dollars. 1 euro is 5.62251 pesos. So all we have to do here for this first problem is just copy that with dollars attached, $1.351 per 1 euro. Okay. Now, the second one is asking for some number of euros per 1 American dollar. So the opposite here. But that's what that second column, or I guess this is the third column, gives us, where it says in EUR. So I guess that's in euros. Yeah, right, in euros. American dollar in euros is going to be equivalent to 0.74, etc. So 0.7, what is it, 40192 euros per 1 American dollar. And we put our dollar symbol in front of the number, so I'll stick with that. I messed that up here. I put dollars behind it, but there we go. 0.740192 euros per 1 American dollar. And by the way, if I flipped this fraction and did the division, so if I flipped this upside down and did, in your calculator, if you do 1 divided by 1.351, you'll get this number, 74, etc. And if I flip this fraction upside down, put 1 over this number, so 1 divided by 0.740192, I get this number back. So these two fractions are the same, they're just flipped upside down and then divided out to make them have a nice clean denominator of 1. Okay, so then part C says that Emma is considering taking $200 for spending money on a trip, I guess. Approximately how many euros will she have to spend? So instead of writing that all out, I'm just going to say $200 is how many euros? because I sent you the picture of the whole example so you can see all these problems written out. Well, which one would we use here? We're looking for euros, right? We're looking for euros. So let's set it up this way. $200 per some unknown number of euros, X number of euros. Okay, and now how do I know which one to set it equal to? Well, because of the way I've set up my proportion, the left-hand side of my proportion, I'm going to want to choose the one that corresponds, that has dollars in the top and euros in the bottom. If I had set my left-hand side of the proportion upside down, like X over 200, then I would use the other one and I would get the same answer. The point is, in the proportional equation here, you need the units to match straight across. All right, so now this is going to give me, I'm just going to kind of skip the steps in between. You would remember, you could just cross multiply, right? End up dividing by 1.351. And what do we get here? 200 divided by 1.351. Approximately, say approximately 148.04 euros. Cool. Okay, so part D is interesting. It says she sees a, oh, there's the symbol for euros. She sees a leather bag priced at 200 euros. How much is this over her budget? In dollars. Oh, in American dollars. Okay, so the question actually asks how much does this bag cost in American dollars, but really what does she want to know? She wants to know how much is this over her budget in American dollars. Well, in euros, how much is it over? Well, she's got, the bag is 200 euros and she's got 104. If she spends every dime she has on this bag, then she would just subtract, right, 148.04. So it's how many euros is it over? It's 51.96 euros over her budget. So now we want to say, well, what is that in freedom units in American dollars? We'll set this up and say, we'll set up a proportion here with some unknown number of dollars, and the way we've set it up, we would want to use, so I'll start using this symbol instead of the word euros now that I know what it is. There we go. We're using this proportion, and I'll just say that would turn out to be X equals, so cross multiplying, lots of calculator work here. Well, not too much, right? You would essentially just end up doing this 51.96 divided by this awful decimal number, just following the path that I did 0.90 for that other example where I wrote out all the steps explicitly. And we're getting in dollars 70.198, so I'm going to round that to $70.20. So the total cost of the bag, by the way, the total cost of the bag, which is what the problem wants, is going to be the $200 that, the 200 American dollars that she brought, plus, because that's the 148 here, plus the extra $70. So it's going to be $270.20. But really, in the real world, what she's going to want to know is how much is it over her budget? $70.20 is the answer there. Okay, so that's using unit rates and proportional equations. That's all I got today. I'm going to give you, I don't have any problems circled yet for to mark for review. Let me stop the recording.